right, the next skill we're going to review is balancing chemical equations. So balancing means making sure that the same number of each type of atom appears on both sides of the equation. This follows the laws of conservation of mass. Mass doesn't get created or destroyed, so if it's present in the beginning of the reaction, it has to be present at the end of the reaction. Some helpful tips: never change subscripts. So as we just did with all that naming stuff, the subscripts are set to make the compound. That's the reason that they bond together. The only thing we can do is change coefficients. There's kind of a rule of thumb that when you're balancing, you can start with the metals, then go to the nonmetals, and then hydrogen and oxygen last. It's a common order for complex reactions. I do find sometimes I want to do oxygen first. So this is just a recommendation, it's not a rule. But they often say save hydrogen and oxygen for last if they appear in multiple compounds. But even then, sometimes I've started with them first for multiple compounds, and everything else kind of happens if I do that right. You are allowed to use fractions when balancing, but if they appear, then you would multiply all the coefficients by a number that clears them. So you would destroy the common denominator. So I tend to just not do fractions at all. So here we go. We're going to start with having nitrogen plus hydrogen going to NH3, which I believe is ammonia. Is that what NH3 is? Is it even in our polyatomics? Nope. But I believe NH3 is ammonia. You guys can write in the comments if I screw it up. When we look at this, we have 2 nitrogens on the left, but we only have 1 on the right. We have 2 hydrogens on the left, and we have 3 on the right. So this is not balanced for any element. So how are we going to balance it? Well, these are all nonmetals, and so we're going to start with our nonmetals, and we're going to maybe leave hydrogen to the end. So if I have 2 nitrogens, and only on the left and only 1 on the right, if I put a 2 here, now I'm balanced in my nitrogens. But now on the right-hand side, I have 2 sets of H3, which means I have 6 hydrogens. To balance that, I can put a coefficient of 3 in front of my hydrogen, and then I'm balanced. Let's try another one. This one, I have potassium ClO3. Man, it's funny, we just did that whole naming thing, and then they can still throw ones on here. Chlorate. So this one is potassium chlorate going to potassium chloride plus oxygen. We've got 1 potassium on the left, that's my metal. I have 1 potassium on the right, balanced. I have chlorine, I have 1 chlorine on the left, I have 1 chlorine on the right, balanced. Then I move to my oxygens. 3 on the left, 2 on the right. So I want to make it 6. That would be kind of a common multiple that they could go into. And so if I put a 2 here, now I have 6 oxygens. And if I put a 3 here, I have 6 oxygens on the right. What'll often happen is that as soon as you put on a coefficient, it'll mess something else up. So now I have 2 potassiums and 2 chlorines on the left, but luckily I can simply fix that by putting a 2 there. And now everything is balanced. All right, for this one, first thing I look at is my metal, so I'm going to look at my sodium. Again, it's already balanced. Then I move to my fluorines, so I have 2 fluorines on the left and only 1 on the right. So I'm going to put a coefficient of 2 here. And again, that made a ripple effect. Now I have 2 sodiums, so I'm going to go back and I'm going to put a 2 on my sodium chloride. That has now made it that I have 2 chlorines, but that's balanced with this diatomic element on the right. And then I have 2 fluorines and 2 fluorines. Yay, I'm done. I maybe didn't need to put all these examples. When I look at this one, I have 2 hydrogens on the left. I have 2 hydrogens on the right. I'm all good. But then my oxygens aren't balanced. I have 2 on the left and only 1 on the right. So I'm going to put a 2 here, but that made me have 4 hydrogens. So I'm going to put another 2 here. It's kind of just playing. I mean, and you either kind of like balancing equations or you don't. All right, so now I have lead hydroxide plus hydrochloric acid goes to water and lead chloride. I'm going to start with the leads. My leads are balanced, good to go. I'm going to move on to my chlorines. My chlorines are not, so I'm going to put a 2 on this chlorine. So metals and nonmetals are balanced. Now I'm going to move on to my oxygens and my hydrogens. These ones are complicated. So if you look at it, I have a split up hydrogen. On the left, I have 2 hydrogens here and another 2 hydrogens here to make 4 hydrogens. So I am going to put a 2 here to balance the hydrogens left and right. That now made it that I have 2 oxygens, but luckily I needed 2 oxygens to balance the left-hand side anyway. So they often kind of happen like that, where you just sort of roll with an element and it'll end up working out that everything, you'll put a 2 here and that makes a subscript 2 or make into 4, but that's what you wanted. So I find balancing equations kind of magic. Go and give a bunch a go.